Good morning, students. Now we are going to see topic 3, thermodynamic process from lesson 7. The thermodynamic, the method of operation which can bring out a change in the system is called thermodynamic process. The change in the system means a heating, cooling, as well as expansion, and as a compression, as well as fusion, a vaporization. These are all examples for the thermodynamic changes in the system. And we have different type of a thermodynamic process. The first process, reversible process. In this reversible process can happen slowly in either direction. The reversible process should be in slow manner. Irreversible process involves net increase in entropy. It can't go backwards. This type of illustration are right for a simple ideal gas. One more thing, isothermal process. Here the constant temperature. Thermal means it's a constant temperature. Isobaric process. Here the constant pressure. And ISOCHORIC process, constant volume. Adiabatic process, no heat is added, no exchange of heat. And last one, cyclic process. Now we are going to discuss about these methods, these types of thermodynamic process. The first, irreversible process. So what is the irreversible process? One in which the system and its surroundings cannot be returned to their initial state before the process is started. You may know that already all the biological process, all the natural process is an irreversible process. A childhood, so become adult man. A childhood girl or boy will become adult. It cannot return back to childhood. And growing of tree also, it cannot be returned back to its saplings, isn't it? And the water falls from the hill, it cannot go back to its hills, isn't it? So these are all irreversible process. It is actually surroundings as well as system are not equilibrium with each other. Surroundings as well as system not equilibrium with each other. So this is known as irreversible process. And next one, a reversible process. One in which the system and its surroundings. The thermodynamic process, exchange of heat energy as well as system to surroundings, the surrounding to system can be returned to their initial state before the process occurs. So we may know this. You have conditions. For reversible process won't take place. It should be in slowly, as well as the first condition for reversible process is the reaction should be takes place in slow manner, as well as the system and surroundings must be in equilibrium. Suppose if you are melting of ice, the ice can be returned back to water. Once again, the water can be freezing of ice, isn't it? This is one of the examples for reversible processes. We have many reversible processes. See in this picture, the boy is blowing the air. The air goes into the balloon. Suppose if you are releasing the air to outside, the air is coming out. So it is also reversible process. So many reversible process, but here the system as well as surroundings should be in equilibrium with each other. This is known as reversible process. Next one, adiabatic process. Adiabatic is a term for process in which there is no net exchange of heat. So there is no exchange of heat, although the adiabatic process have no exchange of heat into or out of the system. This is known as adiabatic process. Here the two type of a process we are going to follow. Here work done by the system as well as work done on the system. If the work is done on the system, suppose if his work is done on the system, automatically the temperature is decreases. The work is done by the system, the temperature is increases. So here for adiabatic process, no heat exchanges. It means the Q is equal to 0. According to first law of thermodynamics, the del U is equal to Q plus W. The del U is what? Internal energy. Q is what? Heat. W is what? Work. here the Q is 0, isn't it? The Q is 0 means what happened here? Del H is equal to 0 plus W, isn't it? So now it will come automatically del U is equal to W. In this process, the decrease in internal energy is exactly equal to work done by the system. So the done by the system automatically it is Q is equal to 0. There is why no change in heat. So we shall take one example for this adiabatic process. In this example, the vertical flow of air in atmosphere, the air expands. So air expands and cools as it rises and contracts and grows warmer as it descends. This is one of the example. Another example is when on industrial or gas clouds expands or contracts. So what happens, expands or contracts? The adiabatic changes are usually accompanied by change in temperature. So there is no net change of heat. So simply you can remember adiabatic processes, no heat exchanges, Q is equal to 0. Next process, isothermal process. For an isothermal process, there is no change in the internal energy. So del U is equal to 0. U is equal to internal energy. So what is the formula here? What is the formula here? It is del U is equal to Q plus W. So del U. So del U is equal to Q plus W. So Q plus W. So it is del U is equal to 0 means automatically you may get 0. So Q is equal to minus W. So during an isothermal process, the amount of heat absorbed by the system, it is equal to work done by the system. Q is equal to minus W. So according to first law of thermodynamics, the del U is equal to 0. Here the temperature is constant. Q is minus W. So here the temperature value should be constant. The temperature is constant according to pressure as well as volume. It should be constant value. So here, so for isothermal process, see here the pressure as well as volume. So if you plotting the graph, the isothermal process, here constant pressure. Next, we are going to see isobaric process. Isobaric process, here the isobaric process, there is no changes in the pressure. Pressure remains constant. So pressure remains constant, remember B. So isobaric means pressure remains constant. So del U is equal to Q plus W. So del U is equal to Q minus the W is equal to P del V. W is equal to, so minus P del V, we can substitute the formula for W here, minus P del V. In an isobaric process, a part of a heat absorbed by the system is used for PV expansion of work and the remaining is added to the internal energy of the system. So in this isobaric process, the heat, that is pressure, should be constant. So the Tp is equal to 0. Suppose here if you are plotting the graph, so here the pressure should be, so pressure should be constant. Next, isochoric process. For an isochoric process, there is no work of expansion. So according to first law of thermodynamics, del U is equal to Q plus W. So here the volume should be constant. Choric means volume should be constant. So del U is equal to Q plus W. So what's the formula for W, work? So minus P del V. So del U, Q minus P del V. So what's the value for P del V here? Del V is equal to 0. We are substituting here del V. So if P del V, so it should be constant. So it is del V is equal to 0 means it is also negligible. So del U is equal to Q. During the isochoric process, the amount of heat supplied to the system is converted to its internal energy. This is isochoric process. In this isochoric process, So volume is constant. If you plot the graph pressure as well as volume, see here the volume is constant. This is known as isochoric process. Isochoric process, the volume is constant. So example we can say for combustion process. A combustion fuel in bomb calorimeter is an example for isochoric process. Here volume should be constant. Next one, cyclic process. So in this cyclic process, that series that starts and ends in same state, the process would not isolated. So in this cyclic process, the net work done on the system per cyclic, which is equal to the area enclosed by the path. So in cyclic process, that is del E internal is equal to 0 and Q is equal to minus W. So the refrigerator is one of the best example for cyclic process. In this process, it performs, the refrigerator works to create temperature differences between here closed, so closed system, so interior and its environment. So the refrigerator system or heat engines excepting running is reverse. So the back principles used for refrigerators is expansion of gas and reduce its temperature. So transfer energy from a body at a low temperature to one at a high temperature. So the refrigerators is working in the principle of cyclic process. So here the del U is equal to 0. It means what? So cyclic process, the final internal energy will be equal to initial internal energy. The change in internal energy of the system 0 for cyclic process. So del U is equal to 0. Here del U is equal to 0, del H is equal to 0, as well as P is equal to 0, V is equal to 0, as well as T is equal to 0. So in this cyclic process, I told you, so del U is equal to 0, so Q is equal to minus W. So in this topic, we have discussed about the thermodynamic process. Here adiabatic process, that Q is equal to 0, no heat exchanges, isn't it? Isothermal process, temperature should be 0, it's a constant, so T is equal to 0. Isobaric process, P should be 0, the pressure should be constant, it will be 0. Isochoric process, volume should be 0, it means constant. What is the cyclic process at last? Del E is equal to 0, energy is equal to 0, H is equal to 0, pressure should be 0, volume, temperature, everything should be 0. So in this topic, we have discussed following topics. These topics you should remember. We shall see next class, students. Thank you.